Welcome, students. Today's lesson, we want to be able to multiply matrices. We want to be able to multiply two matrices by each other. And before we jump into this, I'd like you to look at each of these questions and answer yes or no. Are you allowed to take a matrix plus a matrix? Is that allowed? Yes or no? And you can answer these in your head or jot down the answers. What about a number plus a matrix? Can you take a number times a matrix? And then ultimately, are you allowed to take a matrix times a matrix? And before you answer yes or no, or while you're thinking about these, here's some kind of examples you can look at. Let's run through these one at a time, starting with a matrix plus a matrix. Is this allowed? Well, yes, it is. We are allowed to add these two matrices together, but there is an if. If both dimensions are equal. You can only add two matrices together if they are the exact same dimensions. Now, what about number two? Are we allowed to take a number like 8 and add it plus a matrix? The answer is no. You can never take a simple number like 8 and add it to a matrix. Now, in number 3, what about a number times a matrix? Can we take the number 8 and multiply it by this matrix? Yes, you can always do this, and it's very similar to distributing. What you would actually do in this case is you would multiply all of these elements by 8. Okay. By the way, going back up to the addition problem, the way you would add these is we would just take 7 plus 1 is 8, 4 plus 3 is 7, 2 plus negative 1 is 1, and 1 plus 8 is 9. That's how you would add matrices together. All right, so the first three have pretty straightforward answers. Now, what about the last one? This is the new thing. Are we allowed to take a matrix times a matrix? This is the whole goal for today, is seeing if we can do this. And the answer is yes. But there's also an if that comes with this. And it's kind of bizarre. The only way you can multiply two matrices together is this. It's if the number of columns in the first matrix equals the number of the rows in the second matrix. It's this really bizarre thing that has to happen. Now, one way we'll word this sometimes, so looking at these matrices here, hopefully you notice that this first matrix is a 2 by 2 matrix, and the second matrix is a 2 by 3. Well, the number of columns in the first matrix has to match the number of rows in the second matrix. So sometimes kind of a simple way to word this is we can kind of simplify this by saying the inner dimensions must match. And then another thing you'll come to find is that if these inner dimensions match, this 2 and this 2 match, then the outer dimensions, let me switch colors here, do this in blue. The outer dimensions, this outer 2 and this outer 3, these outer dimensions actually tell you the size of the answer. So the inner dimensions must match. The outer dimensions determine the size of the answer. Okay, so let's start putting this into practice with some actual examples. Oh, and here's, we'll come back to this. There's kind of the textbook definition. Okay, so looking at example number 1, let's first of all decide if it is possible. This first matrix is a 2 by 2 matrix, and I'm trying to multiply it by this second matrix, which is a 2 by 3. Now you'll notice right off the bat, the dimensions don't match each other. A 2 by 2 is not identical to a 2 by 3. But in order to multiply, all that has to happen is that the inner dimensions are equal. And since this 2, the columns in the first matrix, matches the other 2, the rows in the second matrix, this means that the multiplication is possible. And furthermore, I look at my dimensions, my outer dimensions, my 2 and my 3, and I know that my solution is going to be 2 by 3. So right off the bat, when I go to multiply these matrices together, I'm going to actually start with a blank 2 by 3 matrix, and this is where I'm going to write all of my answers. My answer is going to be 2 by 3. All right, so the next question is, well, how do I find the actual elements? Am I going to take 1 times 6? Am I going to take 2 times 1? Am I going to take 3 times 5? What exactly am I going to do here? Well, it's kind of hard to put into words. Let's get kind of a textbook definition of what we do this. How we do this. The textbook explanation of how to multiply two matrices is this. It says multiply the corresponding elements and find the sum of the products. Okay, now it's really kind of hard to put this into words. I'm going to do the best that I can here. What we do, and this will take a little bit of practice, but you'll get used to it. What we do is we're going to take our first matrix and highlight its rows. Now I'm going to use kind of a highlighter color to do this. I'm going to highlight the first row of the first matrix and group those together, the 1 and the 2. And then I'm also going to highlight the second row, the 3 and the 4, and group those together. So the first matrix, we group it together by its rows. Now the second matrix, we're going to group together by its columns. The 6 and the 5 is a group. The 1 and the 7, the 4 and the 2. And then what we do, let me switch back the pen here. What we do is we match the first row of the first matrix, the 1 and the 2, with the first column of the second matrix, the 6 and the 5, and we join them together like this. We take the 1 times the 6 and the 2 times the 5. And then we actually add those products together. Now this is 6 plus 10, and so that's equal to 16. And this becomes my first answer. Now, to find the element, the solution in the first row and the second column, now I'm going to group my first row, my 1 and my 2. But now I'm going to group the first row with the middle column, the 1 and the 7. Now I match the 1 with the 1 and the 2 with the 7 like this. I take the 1 times the 1 and the 2 times the 7. And I add those products together. Now this is 1 plus 14, and so this equals 15. And then finally, to get my last answer in the first row, I'm going to combine my elements in the first row of the first matrix, the 1 and the 2, with the right-hand column of the second matrix, the 4 and the 2. I need to combine this 1 and 2 with this 4 and 2 to get my top right answer, and it works like this. I times the 1 times the 4 and the 2 times the 2 like this. Whoops, that should be a 2 there. Sorry about that. Let me actually fix that real quick. Don't want any confusion. Okay, and this ends up being 4 plus 4, which is 8. All right, now to get my answers in the bottom row, now I'm going to really repeat the exact same process, but this time I'm going to be using the bottom row of the first matrix, the 3 and the 4. So first off, I'm going to group the 3 and the 4 from the first matrix with the left-hand column of the second, the 6 and the 5. I'm going to take 3 times 6 and 4 times 5. Now this is 18 plus 20. This adds up to 38. To find my bottom middle element, I'm going to take the bottom row, the 3 and the 4. I'm going to combine that with the middle column of the second, the 1 and the 7. This becomes 3 plus 28, which is 31. And then lastly, to get my last answer, I'm going to take my bottom row in the first matrix, the 3 and the 4, and I'm going to join it together with the last column of my second matrix, the 4 and the 2. This would be 12 plus 8. This comes out to 20. Okay, so this is my final answer. Multiplying matrices is no walk in the park. This is my final answer. My final answer is this 2 by 3 matrix, 16, 15, 8, 38, 31, and 20. And here on the next screen, it's the same answer, written maybe a little bit differently. See, you can kind of randomly pick, like, let's pick the 8 again. How did we get this 8? Well, the way you get this 8 is, since 8 is in the top row in the third column of my answer, I get it by combining this top row, the 1 and the 2 of the first matrix, with the third column of my second matrix, the 4 and the 2. And when you combine this 1 and 2 with this 4 and 2, just like we did here, That's how we get an answer of 8. Here's kind of the fancy definition. Find the sum of the products of the corresponding elements. Use the rows of the first matrix and the columns of the second. All right. So the next question then is, what happens if we switch the order? What if we take those exact same matrices and flip the order? Are we going to get the exact same answer, or will we get something slightly different? Let's set this one up. Here we have our first matrix is a 2 by 3, and our second matrix is a 2 by 2. And first, I need to make sure that this is even possible. Do the inner dimensions equal each other? Does this 3 equal this 2, these inside dimensions? And the answer is they don't. These are not equal, and so this particular multiplication is impossible. And so when you multiply matrices, the order matters very much. It's very important in what order you multiply them. You'll get a completely different answer either way. I mean, in this case, it wasn't even possible to multiply these matrices if we flipped the order. Okay, here it is again. This is impossible. The inner dimensions do not match. Okay, here's a check problem. Go ahead and hit pause on the video right now. If you want some extra practice, here's a good one to practice with. Multiply these two matrices together. I promise you that this one is possible. Go ahead and hit pause right now, and I'll put the answer up in just a few seconds. And hopefully you had a chance to try this one out. Here is the entire solution, and I tried to show step by step exactly how we got each answer. Our answer is going to be a 2 by 3 with the following elements. Okay, let's jump straight to your assignment now. Okay, so here is question number 7 off of assignment 6.2, and we'll do a couple of more examples directly right off your homework assignment, so you can get practice, get used to how to do this. First off, let's make sure this one's even possible. My first matrix is, so this one only has one row. It's actually called a 1 by 3. My first matrix has 1 row and 3 columns. My second matrix is a 3 by 2. And as I look at these inner dimensions, I see that it is possible. You may look at these and think, there's no way I can multiply these together, but actually you can. It's totally possible. And not only that, but the solution is going to be a 1 by 2. We're going to have a 1 by 2 solution. Okay, so I'm going to write over here, my solution is just 2 elements. It has my solution is going to have 1 row and 2 columns. Okay, so how do we get these answers? Let me pull up my highlighter. I'm going to highlight the rows of the first matrix. I'm going to highlight the columns of my second matrix. And then we're going to start grouping these together. Okay, so my first answer, I'm going to group the row of my first matrix, the -5, 4, and 3, with the left column of my second matrix. I'm going to group it with the 3, the 2, and the -6. All right, and I'll actually show the steps. This is -15 plus 8 plus -18. That adds up to -25. Okay, so there's that answer. Now to get my second element, now I'm going to take the row of my first matrix, the -5, 4, and 3, group it together with the right-hand column of the second matrix, the 2, the -4, and the -6. This could be -10 plus -16 plus -18. Add these together, we get -44. That is my solution. The solution is this small 1 by 2 matrix. All right, let's do one last problem off of your homework before I sign off here. All right, now a lot of students make the mistake on this one. First off, let's make sure that this is possible. We have a 2 by 2 matrix multiplied by a 2 by 2 matrix. This is number 6. These inner dimensions do match, so it is possible. And these outer dimensions tell us the solution is going to be a 2 by 2 solution. So my answer is going to look like this. Now let me show you where a lot of students go wrong on this one. Very common mistake on an example like this. Now here the dimensions do match. You have a 2 by 2 matrix multiplied by a 2 by 2 matrix. Now here's how you do it incorrectly. A lot of students just want to take this 1 times this 6 and say 6. And the 4 times the negative 3 is negative 12. And the 1 times the negative 1, and the negative 3 times the 4. And I wish it was that simple, but it is not that simple at all. That is incorrect. So let's back up a second. Multiplying matrices is much more complex than this. Remember how it's done. Let me get my highlighter out. First, we need to highlight the rows of the first matrix with the columns of the second. And then I'm going to group them together. So to get my top left answer, I'm going to group the top row of my first matrix, the 1 and the 4, let me switch colors here, with the left column of my second matrix, the 6 and the negative 1. This is 6 plus negative 4, which is 2. To get my top right answer, I'm going to take the top row of my first matrix, the 1 and the 4, and group it with the right column of my second matrix, the negative 3 and the 4. This is negative 3 plus 16. This is 13. Now to get my bottom answers, now I'm going to take the bottom row of my first matrix and combine it with the left column of my second matrix. This would be 6 plus 3, which is 9. And then to get my bottom right answer, I take the bottom row of my first matrix, combine it with the right column of my second matrix. As such, this would be negative 3 plus negative 12. The answer is negative 15. All right, so there was a few examples to look at, a few problems off of your homework. This takes a bit of practice. You have to get used to it, but once you practice it, you will become a master at multiplying matrices. I wish you the best on this assignment. Take care.